Well, hello everyone. This is KP the Math G, and we are dealing with partial fractions for the third and final time. Because there's three different types of problems, and so I decided that we would examine all three types. Just as a reminder for the next video, I'm going to pick something from, it's most likely, if you want to look ahead, it's most likely going to be from the 2005 AP exam, and it will be question number 2. And then later on I will deal with question number 1, but I want to address question number 2 first, and it's similar to one that we've done a while back. So they all are going to start overlapping after a while anyway, see, but I just wanted to kind of get you a head start on that. But most likely 2005 question number 2. We'll look ahead. You can look into that problem, and then we'll work it together. If you know absolutely nothing about it, well, we'll help you understand it a little bit better, and hopefully you understand something about it. But if not, that's okay. That's what KP the Math G is here for, isn't it? All right, I'm just here to help and do the best I can, and I will give you my best at all times. Let's start on this problem here, partial fractions. Now look, don't think about factoring this, but we got to factor this. And remember, the last times we just wrote it without the integrand here, so that's what we're going to do. Write it again without that. Now this is of course we can factor out x, and we'll have x squared plus 1, right? Think about it now. Can you factor this? Yeah, well, that one's, yeah, we might consider prime. Cannot really factor that. X squared minus 1, yeah, but that's x squared plus 1, so we cannot do that. Neither can we do this. Thinking maybe we might get this. Let x cubed plus x u be equal to, always forget that u. Let u be equal to that. Then of course du is 3x squared plus 1, and that don't mean you can divide that 1/3 and still have x squared plus 1 there. And actually it's a plus and not even a minus. So now we can't even do that. So that's your first thing you want to look at, though, really. Can you do that, and you have an ln function here, or come up with an ln problem? The answer to that is no. Although we will probably have ln in the final answer, just not going to have it in the initial problem. Now remember what we've been doing. We've been saying put a over the first, we could have done, well, now this one, since it cannot be factored, instead of putting b over x squared plus 1, we want to put bx plus c. And that, excuse me, let me write that down again. X squared plus 1. This is the common thing, okay? If you find that there's something that will not factor, you just go ahead and put that bx plus c here, just like that. Okay, and I have that worked out. Yep, there we go. Okay, and I always like to refer to my notes once in a while, but that's the common thing that you have. In other times, if this had been, well, had this been something like x plus 3, then we would have just done a b over x plus 3 like that. But it's not, okay? This is something, it's in a square term. You cannot factor it, so we do want something in terms of x here, and then plus a constant. Okay, so that is the pattern for doing this type of problem here. This is the only time that you introduce the bx plus c, is when you cannot factor x squared plus 1. We got people working in the attic, so if you hear something, don't panic. We've got a couple of men up there trying to give us some more insulation. Okay. All right. Now let's do what we normally do. We multiply both sides by the denominator. We're going to do that now. So x times x squared plus 1, x times x squared plus 1, and then finally x times x squared plus 1. Okay, now notice that all of this is gone. That's what you want to do. You want to get rid of that denominator. Okay, let me get a different color. See if I can find something that writes a little more solid here. Now we're left with x squared minus 1 here. The x's will go here. We're left with a times x squared plus 1. Okay. And then we are left here, this will go away, and then we're left with bx plus c times x. And there it is. One thing we can do, there's a couple of methods that I would like to show you. There is nothing that, I can get a 0 here. I can plug in x to be 0, and this will be 0, and I can find a fairly quickly. The problem with that is there is nothing that I can plug in here to make a this be 0 here and find b bx plus c. Okay, so okay. Let me show you this method then. Okay, since we cannot find a number that we can square and add 1 to, oh yeah, well, an imaginary number, but I'm talking about a number that is not imaginary. Okay, so I squared I would be just fine, because I squared is -1, and -1 plus 1 is 0. Oh, but we don't want to put I in all this. We want real number solutions here. Okay, so let's do this. I've showed this method before. I'm going to show this method again. All right, let's multiply a times x squared plus a, and then let's multiply x with bx, so we've got bx squared plus cx, okay, and that's equal to x squared minus 1. I'm going to put a 1 in front of that right there. That's the reason for that. Now, what I want to do here is I want to collect my x squares, my x's, and this is just a number. This is just a constant, isn't it? There's no x with it, so it might as well be a constant. And we're going to associate the squares on this side with the squares on this side, with the coefficients. Okay, think about it. I'm saying coefficients. So in other words, this 1 is going to be associated with this A and this B because these have squares. See, this has a square, and this has a square, and this has a square. So let's write it over here. I may have to flip the board over. So there we have, well, I can still write down here a little bit. So let's see, 1 x squared minus 1 is a x squared plus b x squared. I'm putting those two together. Okay, now with the x's plus c, it doesn't matter which one we do next. We'll just put it in order. So plus cx plus a. Alright, now let's set up. Now what we're going to do is we're going to set up a system of equations. Alright. And then what we're trying to do, we got to find A, B, and C. Remember, that's the ultimate goal to start the problem. Okay. So let's go ahead and start on. Let's see. Let's see if we can set it up right here. I don't know if we'll have room or not, but let's see. Alright, so the 1 right here is associated with these two. So that's really actually just the coefficients are A plus B. Alright, so 1 is equal to A plus B. Alright. C, well, I'll tell you what, let's put A plus B equals 1. Let's do it that way. Sorry. A plus B equals 1. Now remember, this is the coefficient of x squared plus this coefficient of x squared is equal to this coefficient of x squared on this side. So A plus B, just the coefficients, equal 1. Okay, C, that's an x. Is there just an x here, just an x to the 1 power? No, there's not. So C is equal to 0. We already know what C is for the, and that's that. That's C is 0. And then now A is associated with something. This constant is corresponding with this constant in it. So this constant A is equal to -1. So A is -1, which now this makes this easy what B is going to be. So A plus B is 1. I'm going to substitute that back in here. And then -1 plus B is 1. And then I'm going to add 1 to both sides. And B is equal to 2. So that was a lot easier than we thought, than we might have originally thought. So here's what we have. A is -1. Just by virtue of the fact that this coefficient is equal to, not coefficient, this constant is equal to this constant. C does not have an x over here. We have an x squared, we have a constant, but we don't have an x. So since it doesn't have anything over here, we set it equal to 0. And then A plus B is associated with x squared, and 1 is associated with x squared. And so that's what we have. That's that system of equations. So A is -1, B is 2, and C is 0. Alright, C equals 0. Alright, there it is. Now, that was virtually harmless, wasn't it? Now, what we want to do is put our -1 here, our B here, which is 2, and a 0 here, right here. Okay, so let's go ahead and do just that. Let's rewrite this so we can see everything. Okay, I'm just going to rewrite it on the other side. I may have to refer back to this side. Already it's x squared. It was x squared minus 1, wasn't it? It was x squared minus 1 over x cubed plus x dx. Okay. Alright, now that equals, now we have to integrate. Well, now we had a. Now remember, a is -1, b is, I want to say 2, and c is 0. We're going to check that, double check that. Now we had a over x, and of course dx, plus integrating bx plus c, that's dx here, over x squared plus 1, right? Okay, like that. Okay. Alright, now let's see. Let's go back to the other side. Let's make sure that we copied this down correctly. Okay, now we have our integrands. We've used a over x bx plus c over x squared plus 1. Got that correct. A is -1, b is 2, c is 0. So we're going to substitute those in. Okay, let's do that back again. Alright, here we go. Now this equals, alright, so -1 over x, -1 over x dx. If I want to, I can put the -1 on the outside and just put the dx up here in the numerator with it. Now -1 like that. There we go. That's the same thing. Because -1 over 1 is, it's still the same thing there. Okay. Alright, so let's see here. Plus now 2x, integrating 2x plus 0 over x squared plus 1 dx. This is going to work out great. We don't need the 0 now, and we just put the 2x in the middle. And this is going to be really nice. I'm just going to leave the 2x there because you'll see what I'm talking about. You know what this is by now, don't you? You got it, ln. Alright, so here we go. -1 times ln of x, absolute value bars, because the ln is never negative. We've got to keep it positive. Plus, now, this is u substitution. Watch what happens here. Let's let u be equal to x squared plus 1. Then du is equal to 2x dx. Don't I have it right here? 2x dx. So really what I have is, I have du, which is 2x dx, over u. That's equal to ln of u, again, equal n plus c, of course. Alright, well, u happens to be x squared plus 1, so really what we have here is ln of, well, I don't need that around here. Now, I'll tell you why not. Or maybe you can tell me why not. I don't need that. Because if I square a negative, it's still going to be positive, isn't it? So I don't need the absolute value bars here. Alright, so, and then of course plus c, right? I just don't need that bar there. Okay. Now, I'm going to rewrite this one more time. And this will, okay, this will be alright right here. Alright, now let me show you what I'm going to do. I like, if I have a negative a plus b, I just like to say b minus a. Even if this is -1, it's still negative, right? Okay, so this is actually a -1, it's just negative, isn't it? Okay, alright, so there's a reason for me doing this. So I'm just going to rewrite this as ln of x squared plus 1 minus ln of x plus c. Alright. Now there is another rule that we're going to write in just a little bit. Ln of a minus ln of b. Remember what that is? That's right. That's ln of a divided by b. Like that. Alright, so this is ln of a minus ln of b. Alright, it's ln of a minus over b. Ln of a over b, right? Alright, so here we go right here. This is our final rewrite. Alright, so this is equal to ln of x squared plus 1 over x, absolute value bars, now plus c. Okay, so the minus means divide. If this had been a plus, we would have put it times each other, but it's minus, so we just divide it here. Alright, there it is. Nice, neat little problem. Came out of this book right here. Just to let you know, I have a book like this right here, and I want to say it was in section 7.5 or something like that. Then chapter 7, I forget what number that was, but anyway, it was in this book here. Okay, yeah, I purchased a couple of textbooks over Amazon, and even though they're not teacher's editions, well, they're all right, they'll do. Okay, so that's what we have right here. Okay, so first of all, the idea here is to factor this. Alright, x times x squared plus 1. If this does not factor, you got to put a bx plus c, or cx plus d, or dx plus f. Whatever, you have to do that. So this is a square that it just cannot be factored, so we just have to let it be. Okay, and that's the format that you use here. And then once you find a, b, and c, then the integration is fairly easy. And I found that we could go ahead and let u be equal to x squared plus 1. I knew this would be 2x dx, so there's my ln of this one. This is ln also, but it's a negative here. Switch the signs around, then just rewrote it like this. There it is. Okay, that's all I have for now. So again, if you want to look at question 2 of the 2005 free response question, be my guest, do that. See what you can get out of it, and then I'll go over it anyway. So anyway, that's all I have for today. This is KP the Math G, wishing you a great day. Please don't forget to subscribe if you haven't done so already, and also make a comment if you'd like to make a comment, or hit that like button. That's always encouraging to get any of those, so I appreciate you so much, and this is why I do this. Again, it's not for my benefit, but it is for you. And it is for my benefit in a way, because I love doing this myself anyway. So, alright, that's all I have to say about that. KP the Math G signing off. Have a great day.